Hello everybody, this is Easy Calculus number 12. We get into vector. The vector is a little bit at the borderline of the high school and the college math. I think it's in the high school AP class multivariables. It talk about the vectors, and vector calculus is definitely part of the college math, but some advanced high school they offer this kind of class too. So let's roll on. The y vector, the one thing you don't want to do in the math learning, you develop the bad habit of accepting everything from school. School teaches something and you don't know why that's a subject you have to learn. You just accept it. Some student question like this kind of question, y vector, do we have anything else that is better than vector and stuff? Well, we talk a little bit about this. Okay, from elementary school we learned rational number, right? And the rational number handle almost everything around is algebras until you come to the point that somebody asks a question. When you multiply itself become 2, what is that number? And this is the algebraic equation is x square is 2, and rational number cannot handle it. Now we immediately expand number into irrational number. So square root is the answer. Square root is not in the scope of the number category before. Now you have to include that, and we call that a real number, right? Then some algebraic equation you cannot even solve because sometimes you get negative 2. What do? So we introduce imaginary number. The imaginary number is not within a real number. So we include that and called complex number. This complex number a plus bi, function of complex number is going to be complex number again. Okay, fine. We use that to solve some algebraic equation. Now you come to think of it, when you draw this, the real number goes here. We have to have a complete another set of real number on this axis, and we put the I. Then we can show this number geometrically because you cannot show by just one line. That's a real number occupied here. So you have this number and this number. Naturally, if you show this kind of geometric figures, you want to see if it can be used for solving some geometric problem. For example, from A to B, what is the distance, right? So if point A is A plus bi and point B is C plus di, so if you subtract B minus A, right? So it's going to be C minus A plus D minus B, and this is I. So that's going to be this section. What is length? It's going to be c minus a square plus d minus b square. That's going to be the length, right? So and so. But it's not that useful, right? You cannot solve many geometrical problem. But in the college math, there is a subject called complex number theorem. So they expanded to define derivative and integral of complex number function. Then it's quite useful for certain problem. In order to solve some problem, it can be used, but not as much as the physical geometry. Okay, so that's the end of it. And the complex theory is useful in various area, but if you come to the physical dimension, right, you have x, y, z, we need something else, and physics demanded physics in order to solve this space, our space, 3D space. Complex number is not so useful. So just like this idea I, let's get this direction I, j, k, define the direction, 3 different directions, and you cannot add ai plus b, j. They are different direction. You can't just say a plus b something here. Okay, 3 different direction. And can we define the mass? Yep. Let's say I is unit length this direction, j is unit length, k is unit length. So any space can be described by ai plus bj plus c k. Vector can tell you exactly where. So we start defining a new number. Oh yeah, forgot to tell you, you already learned something else. Irrational number, imaginary number, you learned a new number in calculus. What kind of number? Infinity, infinitesimal, small number, right? And the number like it's infinitely close to number 2. So we don't have good notation for that. Okay, mathematicians use only limit, but limit is not infinitesimal number. Limit means the number infinitely close to 2, the limit is 2. Limit merely tell you, okay, when it's go infinite effort to get close, where does it reach? It's reached to 2. That's what it means. Okay, so we don't have a good notation. I use 2 plus because it's a little bit bigger than 2, but infinitely close to 2. This kind of number is that the real number? Well, you check math book, see if it's answered your question. It's a real number, but it's not, right? It's a new number. the number which is close to 3 infinitely is a real number somewhere on the real number line. You cannot just show by putting a dot on it. You can't specify the location, but it's number, and that's a number we use to develop calculus, right? So calculus is based on this kind of number. Now we're talking about vector, and the vector is AI plus BJ, this vector plus CI plus DJ can be A plus CI plus B plus D. The same kind you can add together. So we set this rule. This is a rule. It's not a characteristic or property. It's just a rule. We set, add, and subtract rule on this vector. Okay. So then how do you multiply the number, vector number? It's like vector A multiply vector B. Okay. Say vector A is this direction A, and the vector B is this direction. So what we do is, B minus A is going to be this vector like this, right? If A minus B, then the vector is this direction. Now we define multiplication, but this is one of multiplication. If vector A is AX plus AB, AY, and vector B is BX, not plus, and BY, then vector A, vector B is AX multiplied by BX plus AY multiplied by BY. And this is not vector, this is scalar. Okay, so once you multiply, it became scalar. What does it mean? Length square is going to be this length square and this length square, right? Pythagorean theorem. Okay, so this length is B sine theta square plus this length is A minus B cos theta square. So it's going to be B square sine square theta plus A square plus B square cos square theta minus 2AB cos theta. Now this one, the sine square and the cos square is 1, so it's going to be A square plus B square minus 2AB cos theta, right? So this, you can get this let's see, this is the length formula of this triangle, actually cos formula, right? So this cos formula is going to be A minus B, like that. Okay, so the point here is vector, you just do add or subtract and take the absolute value. Absolute value is the vector's absolute value is xa square plus b x using this ax square plus ay square square root. So it's corresponding. So we can get geometric calculation using vector. Okay. And how about area? There is another multiplication defined. This is called inner product. And outer product, we write this x instead of dot. Okay, so we define this outer product using matrix I, J, K for 3-dimension AX, AY, AZ and stuff. Okay, so this can give the area of triangle, but this product stay as a vector. So area has direction. Well, if you have vector A and vector B, and if you write B times A, the vector is going to be this, means the hip of the arrow. If A multiplied by B is going to be the front tips of the arrow. Okay, so direction is going to be orthogonal to A and B, and the vector size is going to be this area defined by A and B. Okay, so this is the basic vector algebra. Okay, now we are going to get into calculus. So when you have, say, 2-dimensional vector, right, then z is going to be x and y, but x vector j, this kind of function. So how do you define the differentiation, derivatives and integration? Derivatives is you need to have direction, which direction you look at to get the slope, right? So naturally you look at this parallel to I, this derivative, and parallel to j, this derivative. So you're going to have, if you have a z, you're going to have derivative with respect to x. So we write or z x, and z derivative with respect to y, zy delta dz dy. Okay, so then any direction can be the combination of this using this vector I and j. So the slope of this multivariable function can be described by this slope vector combination, right? So that's what we use in the physics, this notation. Slope of z is going to be slope direction of I plus slope direction of y. And if 3D, if z is like not surface like that, but you know, the density function, like density function, you can have 3D. Okay, so this is going to be the derivative function of multivariable using a vector. Okay, without using a vector, you can have derivative which is this. And now two different derivatives. So this is the part the most of students get confused. What is the difference between this and this? When z is function of x, y, z, or vector form, that's what we talk about in the next video. Okay? If you like this video, please subscribe and wait for the next video.